Okay, this is AP Chem topic 3.12, properties of photons, aka light equations, and I'm going to show you this by showing you a foldable. Let's first talk about relating wavelength and frequency. So if we think about the speed of light, the value of speed of light is a constant, which is 2.998 times 10 to the 8th meters per second. This is on the equation sheet, and this is a value that you might have heard before, especially if you've already taken physics. So then this funny looking letter here is lambda. That's the lowercase Greek letter lambda, and this is the lowercase Greek letter nu. It looks like a V, but it's actually nu. So wavelength and frequency have an inverse relationship, which means that as wavelength goes up, frequency goes down, and vice versa. And that should make sense if you stop and think about it. If we make the wave longer, it's going to pass by a specific point less often, and vice versa. If we make the wavelength shorter, it's going to pass by a specific point more often. Now let's think about how we use those in an equation. So the wavelength units are meters, and that's what it needs to be in this equation so that it matches the units on the speed of light. But often the units for wavelength are given in nanometers, especially when we're talking about visible light, because the visible light spectrum, part of the spectrum, is in the nanometer wavelength region. So you need to know that 10 to the 9th nanometers is equal to 1 meter, or we can flip that around and say 10 to the negative 9th meter is equal to 1 nanometer. And there is a version of this conversion on the equation sheet. So new, they have added the SI prefixes to the equation sheet. Then we can think about frequency, and the units of frequency are 1 over seconds, or seconds to the negative 1, or hertz. These are all the same thing. This is just 3 different ways of writing the same unit. So now we can think about using this in a calculator. Now let's look at relating energy and frequency. So energy now is equal to h nu, and then I want to point out to you that the one variable that is in both of these equations is the frequency. So E is energy and its units are joules. H is a constant. It's called Planck's constant, named after the man that discovered it. This value is 6.626 times 10 to the negative 34th joules times seconds. This is also on the equation sheet. So then your nu is still frequency. Your units are the same as what they were up here. Now, the thing about these two equations is you can use them together because frequency is the common term between them. So you can know the wavelength and actually calculate the energy. You just have to go through frequency in order to do it. So my work is a little all over the place here, but let me show you a quick example. So if we have a spectrum here and the question is at what frequency is the maximum absorbance seen? So then here's the maximum absorbance, it's the highest peak, and so that value is marked for us here as 471. So that's 471. Now we do need to convert that. That is in nanometers. We need to convert that into meters. And so when you do that conversion, then it works out to be 4.71 times 10 to the negative 7th meters. And then we can plug that into this equation. So I plugged in my value for C. This is my wavelength, 4.71 times 10 to the negative 7th meters, and then my frequency is here is unknown. So then you divide to solve that equation, and you get 6.37 times 10 to the 14th hertz. Now, one thing I want to point out is a really common way for students to have an error when they're doing these calculations is to improperly use their calculator. You either need to use parentheses around your scientific notation expressions, or you need to use the EE button. The EE button is my favorite. So you do 2.998, you can see where I did it up there, second, EE. And on all Texas Instruments calculators, that's TI-30X2S and above, it's going to be right here over with the comma button. And then you just type in the exponent. Now notice here, there is no time symbol, there is no caret button, nothing like that. That tells your calculator this is my base number, this is my exponent, and that is a single value. And then you can divide it by your frequency, which again here was 4.71 times 10 second. E, that's the times 10, negative 7. Make sure you use the negative button and not a minus key. And then enter. And then it will tell you your answer again in that format for scientific notation. So then, as I mentioned, we can come down here and we can use that frequency then to calculate the energy. So I can take this frequency and plug it into my E is equal to h nu equation, multiply them together, and get an answer. And then this is my energy that corresponds to that wavelength. So there you go. That is topic 3.12, properties of photons and how to do some calculations with them.